Okay, for the next topic is about eigenvalue and eigenvector. See, a problem that leads to a concept of crucial importance in many branches of mathematics and its application is that of seeking non-trivial solution of x is not equal to 0 to a metric equation of ax equal lambda x. So means this above referred to the eigenvalue problem. Value of scalar lambda for which the non-trivial solution exists are called eigenvalue, and the corresponding solution if your x equal not equal to 0 we call as eigenvector. So in terms of equation, the set of simultaneous equation we use is ax equal to lambda x. So which is A is your matrix, which is m times n matrix, and it is in terms of written form we can use the concept of lambda times I is the identity, minus A your matrix, times x equal to 0, where I is the identity matrix, and the above equation can be simplified to be C lambda equal lambda I minus A equal to 0, where this C lambda is the expansion of determinant in its polynomial of degree lambda, which is called as characteristic polynomial of A. Okay, so we can show you some example. Okay, related to eigenvalue. Example, find the value of lambda for which x plus 4y equal to lambda x and 2x plus 3y equal to lambda y. Okay, so in order to solve the solution, okay, we mentioned previously that this form can be written as ax equal to lambda x, where is your a is equal to 1, 4, 2, 3, and your x is equal to x and y small. Okay, so for non-trivial solution, as mentioned previously, okay, we can use the formula, okay, of A your matrix minus lambda I your identity is equal to 0. So here your A minus lambda I is equal to, what is your A matrix will be 1, 4, 2, 3, okay, minus lambda I is identity is 1, 0, 0, 1. Okay. Okay. So from here, okay, from here we can see that this one can be solved to be 1, 4, 1, 2, 3, so become minus lambda 0, 0 lambda. So, or in easier way is it will become 1 minus lambda. This is your second metric. 4 with which 2 means 3 minus lambda. Okay, so we know that from here we can solve this on the modulus of a minus lambda I is equal to 0 just now is we just find the determinant of 1 minus lambda a times 3 minus lambda a plus minus 8. So you will get lambda square minus 4 lambda minus 5. So from here, so to have non-trivial requirement, this one can be factorial to become 4 lambda minus 5 equal to 0. Okay, so you will get lambda plus 1 times times lambda, you will get plus lambda minus 5 equal 0. So here you will get your automatically lambda. You have two coefficient, which is lambda equal to -1 and lambda equal 5. So this is the given system that has non-trivial solution, where is your lambda should be lambda equal -1 and lambda equal 5. Okay, for the eigenvalue. Okay, maybe we can go for the next example. For example, determine the characteristics of equation and eigenvalue lambda in this system. Okay, we go for example number 2. Okay, in order to solve this one, as mentioned, is we have to use the formula of eigenvalue, which is a minus lambda I dt is equal to 0. So you can just get it short to become 3 minus lambda, okay, 1, which is -1, 5 minus lambda, okay, it become 0. So here you will get 3 minus lambda times 5 minus lambda plus 1 is equal to 0. You will get lambda square minus 8 lambda plus 16 equal to 0. So from here you can factorize this one, become lambda here, we have 4 here, 4 here. This is negative, should be minus, and minus equal to 0. So your lambda will be 4. You have twice of the data. So your eigenvalue of lambda is equal to 4. Okay, this is for eigenvalue. Okay, what will happen if we have 3 times 3 matrix to find the eigenvalue? For example, this one. Okay, so in order to solve this one, we use the same formula, which is modulus of a minus lambda I is equal to 0. So you can change this metric to become, putting the lambda, so it will be 1 minus lambda 2, you have 0, you have negative 1 minus lambda 1, then you have 3, 2, negative 2 minus lambda. If you notice here, the lambda will remain at the diagonal of identity. This is your matrix. Then in order to solve this one, you can select the determinant of this one, so it become 1 minus lambda first row, so you will remain the negative 1 minus lambda 1 3 2 2 minus 2 minus lambda. Okay, then you have second one minus 2, so you have negative 1 1 3 negative 2 minus lambda. Then the last one will be 0, so no need to add, or times 0 here. So here you can solve it. You will get 1 minus lambda times negative 1 minus negative lambda times negative 2 minus negative lambda negative 2. This is the first one. Okay, minus 2 negative 1 negative 2 minus lambda negative 3. So at the end, when you simplify this one, you will get negative lambda power of 3 minus 2 lambda of 2 plus lambda plus 2. Okay, as we know that the main formula eigenvalue is A minus lambda I equal to 0. So this equation we can equal to 0 become negative lambda power of 3 minus 2 lambda power of 2 plus lambda plus 2 is equal to 0. Okay, so here you can see that the equation, okay, for the first one, the question asks you to find the A characteristic of equation. So this is your characteristic of equation. Then the for B1 is the eigenvalue of A. So you need to find the eigenvalue of A. Whereas from this characteristic equal to E0 means that, okay, you have from here you times negative 1 everything. To make things easier, you will get lambda 3 plus 2 lambda 2 minus lambda minus 2 equal to 0. So here you can factorize it to become 3 factorized, which is lambda plus 2 lambda plus 1 and lambda minus 1 equal to 0. So automatically you will get your lambda is equal to negative 2 negative 1 and also 1. So this is the eigenvalue of lambda, okay, which is this one. Okay, next is all related with eigenvector. Okay, what is eigenvector? Eigenvector is based on Ax equal to lambda x, so which is we determine the value of lambda for which non-trivial exists. Okay, the value of lambda just now we call it eigenvalue of the system. Okay, so the eigenvalue of A just now we calculate is lambda. For each eigenvalue there is non-trivial solution of system. The solution called eigenvector. Okay, so now lambda is an eigenvalue, then the solution of that equation we call it as a eigenvector. Okay, for example, we go to this example. Okay, previously this is the same example as here. determine the characteristic of eigenvalue of lambda, which is we already calculate how to get the lambda, and the final lambda is become 4. So now the question asks us to calculate the eigenvector. So we know here, that based on the previous calculation, we know that the lambda is equal to 4. So in order to solve the eigenvector, okay, this is the eigenvector. So the formula is a minus lambda I times x is equal to 0. So means a minus lambda I is equal to, this is your main matrix, okay, minus your lambda is already known, which is 4 eigenvalue, then your identity is 1 0 0 1. Okay, so from here we can calculate, we get the solution of -1 1 -1 and 1. Okay, so here okay, so means here so we know that a minus lambda a, okay, based on this equation, so this one becomes here, so means a minus lambda I times x is equal to 0. So a minus lambda I is equal to -1 1 -1 1 times x, which is xy, is equal to 0. So we can take the first equation, the first line, this one. So what you can get is -x plus y equal to 0. So which has an infinite solution. So we get, for example, is x equal to t and y equal to t. So means if we take this solution, we get only one eigenvector, where is your main x is equal to t times 1 1. Okay, this is example for eigenvector previous. Okay, now what happen if we have 3 times 3, we have this type of equation. Okay, we have determine the eigenvector of this 3 times 3 matrix. If you notice, previously I have teach you how to calculate the eigenvalue of this equation. So from here we get our lambda. We have 3 type of lambda here. Okay, so this is a eigenvalue. Your eigenvalue will be -1, -2 and 1. Okay, so the continuous of this equation is determine the eigenvector of this equation. So now we already know that the eigenvalue from the previous will be -2, -1 and 1. So in order to find the eigenvector, we need to do one by one. For example, we are taking lambda is equal to -2. So your main matrix will be 1 2 0, -1 -1 1. Then you have 3 2 -2. then you have x, y, and z. Then you have the lambda, which is -2 times x, y, and z. Okay, so here, based on the previous main equation, so is that a minus lambda I, okay, times x is equal to 0. So what is your a? Okay, so what can say our a is 1, 2, 0, -1, -1, 1, 3, 2, -2. This is our a. Okay, minus lambda. Lambda is -2. Now our lambda is -2, become +2 times, what is your identity? Become 1, 0, 0, 0, 1, 0, and 0, 0, 1. Then you have your x, y, and z. Then you have your equal kosong 0, 0, and 0. So when you solve this one, then you will get your simplification become 3, 2, 0, -1, 1, 1, and 3, 2, 0. Then you have your x, y, z equal to 0, 0, and 0. So from here we can solve identical for each row. So the first row, what we have, 3x plus 2y is equal to 0. The second, we have -x plus y plus z is equal to 0. Okay, so for example, we are taking x, take one of the unknown equal to t, so everything will be under t. Okay, so what you have is your y will be, calculate, put it t, 3t, your y will be -3/2t, then your z will be 5/2t. So hence, okay, your eigenvector is your big X is equal to t, then you just put 1, which is your x is 1, your y is -3/2, then you have 5/2. So this is the how to calculate the eigenvector. For your lambda is -1. So rest, you start to do the lambda is 1, lambda -2. Then you have a lambda -1, then you will get the answer of here. Okay, this is your answer. Okay, then you put lambda equal 1, then you will find the answer of eigenvector. Okay, this is how the concept of eigenvector and eigenvalue. Thank you very much.